Good day everyone, I am Rosemilin C. Pilenio and together with Miss Christine Joy Chavet, we are to discuss on relativity, which is in topic 1A, describe the theoretical and experimental issues that Einstein's theory of special relativity addressed. Let me start with the learning objectives. So at the end of the discussion, the students are able to understand the concept for developing the theory of special relativity, describe the theoretical and experimental evidences, and then recognize the importance of Einstein's theory of special relativity in real-life situations and natural processes. Albert Einstein's 1905 theory of special relativity is one of the most important papers ever published in the field of physics. So special relativity is an explanation of how speed affects mass, time, and space. The theory includes a way for the speed of light to define the relationship between energy and matter. Small amounts of mass can be interchangeable with enormous amounts of energy, as defined by the classic equation is equal to mc squared, or the energy equals mass times the speed of light squared. Albert Einstein has major contributions in the field of physics, which includes the Avogadro's number, quantum theory of light, general theory of relativity, special theory of relativity, the photoelectric effect, wave-particle duality, Brownian movement, and the relationship between mass and energy, Bose-Einstein condensate, to name a few. As an object approaches the speed of light, the object's mass becomes infinite, and so does the energy required to move it. That means it is impossible for any matter to go faster than light travels. This cosmic speed limit inspires new realms of physics and science fiction, as people consider travel across vast distances. So as seen in the illustration, it conveys that the conventional notion of absolute universal time is replaced by the notion of a time that is dependent on the reference frame and spatial position. And in relative theory, reference frames play a vital role. It is used to measure a time of events by using a clock. An event is nothing but an occurrence that refers to a location in space corresponding to the reference frame. For instance, the explosion of a fire flower can be considered as an event. So let us move on with the experimental aspect. So Einstein stated that the theory of relativity belongs to a class of principal theories. As such, it employs an analytic method, which means that the elements of this theory are not based on hypotheses but an empirical discovery. By observing natural processes, we understand their general characteristics, devise mathematical models to describe what we observed, and by analytical means, we deduce the necessary conditions that have to be satisfied. Measurement of separate events must satisfy these conditions and match the theory's conclusion. So there are issues that arise saying that relativity is falsifiable theory. It makes predictions that can be tested by experiment. In the case of special relativity, this includes the principle of relativity, the constancy of the speed of light, and time dilation. The predictions of special relativity have been confirmed in numerous tests since Einstein published his paper in the year 1905, but 3 experiments conducted between 1881 and 1938 were critical to its validation. In addition, Einstein's theory of special relativity is sometimes presented as if it were a piece of philosophy or mathematics that arose purely from abstract thinking about space and time. Well, this is not the case. Einstein based his theory firmly on experimental results known to him. Subsequently, the implications of his theory have been widely tested over the past century. No repeatable and generally accepted experiment has been found in disagreement with special relativity. Special relativity is built into the woodwork of modern physics. Its results are used all the time in the areas of physics that use these results work very well. Although some of the results of special relativity are counterintuitive, in hindsight, what Einstein did now seems natural. He realized that the incompatibility between Newtonian mechanics and electricity and magnetism should and could be resolved by rewriting the old mechanics and not the new electricity and magnetism.
Theoretical aspect. If a person could theoretically catch up to a beam of light and see it is frozen relative to their own motion, would physics as a whole have to change depending on a person's speed and their vantage point? Instead, Einstein recounted he sought a unified theory that made the rules of physics the same for everyone, everywhere, all the time. This road to physics led to his eventual musing on the theory of special relativity, which he broke down into other thought experiment. A person is standing next to a train track comparing observation of lightning storm with a person inside the train, and because this is physics, of course the train is moving nearly the speed of light. Einstein imagined the train at the point on the track equally between two trees. If a bolt of lightning hit both trees at the same time, the person beside the track would see simultaneous strikes. But because they are moving towards one lightning bolt and away from the other, the person on the train would see the bolt ahead of the train first and the bolt behind the train later. Einstein concluded that the simultaneity is not absolute, or in other words, that a simultaneous event as seen by one observer could occur at different times from the perspective of another. It is not light speed that changes, he realized, but time itself that is relative. Time moves differently for objects in motion than for objects at rest. Meanwhile, the speed of light observed by anyone anywhere in the universe, moving or not moving, is always the same. How Einstein theory important? Einstein theory of relativity has made many new technologies possible. A world without relativity would be a world without cathode ray television, radar guns, and the global positioning system, and more. It's predict, for example, that two clocks keep time indifferently depending on their relative speed and height. Einstein relativity is built into the design of network or orbiting satellites, knowing has a global position system, GPS. Each time we use the GPS, we use Einstein theory of relativity. The theory of space relatively explains how space and time are linked for the object moving at a constant velocity. Time and space are interchangeable. When we move through space, some of the motion can be true of us being divided into motion through time, and vice versa. We cannot move only through space. We move through time also. When we are at rest, we move only through time, but when we have through space also, some of our motion is diverted towards space, and so time is less than it should be, or we can say time is dilated. Those dimensions of space, time affect each other, and both space and time are those relative concepts.